Okay, terminating and repeating decimals. This is Chapter 5, Lesson 4. Make sure you write those at the top of your page and today's date that you're listening to this recording. All right. Here are 4 vocabulary words for this section: terminating decimal, repeating decimal, bar notation, and rational number. You may have run across some of these terms before, and some of them may be new. Leave enough room so you can write the definition as we come across these definitions in the next couple of pages. And here's our first definition: rational number. A rational number is any number that can be written as a fraction. Any number that can be written as a fraction. That's your definition for a rational number. Let me move my recording button down here out of our way. Very good. A terminating decimal, here's the second definition, is a rational number that's, when it's written as a decimal, does not repeat. So it's a number when it's written as a decimal, it does not repeat. So example would be 1.735. None of those numbers repeat. That's a terminating. Terminate means to end. If you get terminated from your job is ended. Okay, if they terminate the game because of poor sportsmanship, the game is ended. So terminating decimal means a decimal that ends. A repeating decimal is a rational number that the decimal repeats to infinity. And an example would be 0.333333333, which, written as a fraction, is 1/3. Remember, well, we'll get into that in just a minute. Okay. Go ahead and write down these definitions. Pause the video so you get everything written down, and then start it back up when you're done. So let's think about this. Jude is buying party fruit snacks. He asks the cashier for a ½ pound. So if we write a ½ pound as a fraction, right, that would be 1/2. As a decimal, what is half written as a decimal? 0.5. And in fact, how you find this out is you take the 1, and remember this line right here means divided by. 1 divided by the denominator 2. And if I actually did this in long division, 2 goes into 1 0 times, 2 goes into 10, how many times? 5. 0.5. And that's how we get it written as a decimal. Remember how to change fractions to decimals? Okay, suppose he asked for 1/3 of a pound. 1/3 of a pound. What would that look like? Well, it would look like what we just saw, 0.333. And on and on and on and on. Okay, we're going to talk about what rational numbers look like. I just made this little diagram, and I'm going to add to it while we talk about it. So we've learned what whole numbers are since, first grade. 8's a whole number, 1's a whole number, 13's a whole number, right? Those are all whole numbers. We've also learned what integers are, and integers are whole numbers also, aren't they? Excuse me, whole numbers are also integers. So other integers besides the ones we talked about, 8, 1, and 13, you might be -6 or -44. Those are more integers. And whole numbers and integers are all part of what's known as rational numbers. But other rational numbers besides whole numbers and integers would be 0.8, 1/4, -1.4444 and on. 5 2/3 would be another example. Okay, so we have whole numbers which are part of integers, but add on the negative numbers. Whole numbers and integers are all part of rational numbers, and add on all of these other numbers, okay? So to see how those are all related. So that's what the family looks like. They have great reunions, right, guys? They all get together for Thanksgiving, and yeah, okay, never mind. Bad joke. All right. So rational numbers, in other words, are numbers that can be written as fractions. We've already talked about that. Some examples are percents, whole numbers, integers, and repeating decimals. Every rational number can be written as a decimal by dividing the numerator by the denominator. All right, so every rational number that we can think of can be written as a decimal. So if I had a number like we did, say we had 2 fifths. That's a rational number because it can be written as a fraction, right? And if I wanted to show what it was as a decimal, I would say 2 divided by 5. 2 divided by 5, right? And if I do that long division, I find out that as a decimal, it's written as 0.4. All right, so all you have to do is divide the numerator, this guy, the numerator, divide it by the denominator. Here's a little chart that shows you some examples of rational numbers. 3/10. A repeating decimal would be 0.300, and the terminating decimal form of that would be 0.3. 4/5 is the same as 0.8 as a terminating decimal. If you could repeat it and add all the zeros on that you want. 5/6, however, can be written as a repeating decimal, 0.8333. You can either do long division or you could get out your calculator and see if, in fact, if you take 5 and you divide it by 6, you'll get 0.6 goes into 58 times 48, a remainder of 2. 6 goes into 20 3 times 18, remainder of 2, 20. And you can see that it's going to keep on repeating, okay? All right, so sometimes we use something called bar notation. And when we indicate that there's a number pattern that repeats, to show that the number pattern repeats, we use something called bar notation. So here's your next definition. Bar notation is a bar placed over the digits, oops, misspelled word there, that repeats. For example, if I have, well, we just had that we had that 5/6, right? And that's the same as 0.8333, and so on. We would write that using bar notation as 0.83. So you may have seen it as something that has a hat over it. You guys may have called it a hat. But we're going to stop calling a hat because we're going to sort of leave that for our lower school terminology. And instead, we are going to be calling it bar notation in middle school. Now, if you had something that repeated like 0.757575, and so on, you would write that in bar notation as 0.75. And the bar would go over the 2 digits that repeat. If you had something like 0.831831, guess what? And so on and on and on. You would write that 0.831 with those over there. If you had something like 0.47272, so on, you would only put the bar notation over the numbers that repeat. Only the 7 and the 2. The bar notation does not go over the 4 because it does not repeat. So there are some examples for you. Okay, here's an example. We have the number 5/12, and we want to write that as a decimal. So we could do a couple of approaches. We could get out our calculators and say 5 divided by the denominator 12. And you could do it longhand if you want, or you can get out your handy dandy calculators and say 5 divided by 12. And in fact, we find out that 5 divided by 12, when I punch it into my calculator, is 0.4166, and so on. And your calculator actually says 6666, and then it changes it to 7, because calculators have to terminate it. So they've rounded. But in fact, what I would like you to do in that kind of situation is write 0.41, and what repeats is only the 6. And that would be your answer. Okay, why don't you guys try one? Actually, try 3. Here they are. Pause the video, write these fractions, punch them into your calculator, tell me what the decimal form of these is. If it's a terminating or a repeating decimal, and if it's a repeating, use bar notation. All right, negative fractions as a decimal. The process is exactly the same when you're dividing negative fractions as it is with positive fractions. You just write the negative in front of the decimal. So for instance, here we have an example, -2/9. And we need to write that as a decimal. So really what we're saying is, sorry, I'm going to make that an arrow, is -2 divided by 9. Again, you could do the long division if you so desire, or you can pick up your handy dandy best friend calculator and say, punch in 2 divided by 9, enter, and you get 0.222, and on and on and on, right? So the correct way to write that is 0.2 with a bar notation over the 2. Okay, let's try this guy, -2 2/3. Well, we have a mixed number here. The first thing we're going to do is change that into an improper fraction. 3 times 2 is 6, plus 2 is 8/3. And now we're going to think, okay, that's 8 divided by the denominator 3, right? Okay. So again, I take out my new best friend, right? My handy dandy calculator and clear it, and I say 8 divided by the denominator 3, and I get 2.66. Again, it shows that repetition across the screen of your calculator. So you will change that to 2.6 repeating. All right, I think I have some for you guys to try. There they are. Go ahead and try those. Again, write the fraction on your page, then punch it into your calculator, numerator divided by the denominator. Don't forget the negative sign. Oh, I might have forgotten the negative sign in that last one, did I? Sure enough, I did. Did anybody catch that? It should have been -2.666. Thank you for those of you who noticed. Okay, good luck with those. Pause it and come back on when you're finished with those 3 problems. All right, Frankie made 34 out of 44 free throws for the basketball season. Round this to the nearest thousandth, okay? What is his free throw average? Oops, sorry. What is his free throw average if he made 34 baskets out of 44. That's how you write it as a fraction. He made 34 out of 44. Well, for this, I am definitely taking out my handy-dandy calculator, and I'm going to say 34 divided by 44. Enter. And I get the number 0.77272, and so on. So how do I write that as a with using bar notation? I would write 0.7, and then it's this 72 that repeats. All right, I think I have one problem for you to try, guys, and that's the end of this video. Here it is, your turn. Go ahead and try this word problem. Use bar notation if it's necessary. Okay? Good luck with that.